In this section, I want to talk to you about the difference between variable cost, fixed cost, and what we call our mixed cost, which are part variable, part fixed. Let's take a look at some of these costs. First, let's take a look at variable costs. Examples of variable costs are your direct materials or your direct labor, anything that relates to how much you produce. A variable cost in total will increase or decrease proportionally with the level of activity. But a variable cost on a per unit basis will remain the same regardless of the level of activity. For example, if my direct materials were $10 per foot, they're always going to be $10 per foot. In total, if I have 10 feet, I will have $100 of material. If I have 20 feet, I would have $200 of material, because as the total increases, my total amount of variable cost will also increase. With fixed costs, we have examples of depreciation, taxes, maybe annual salaries, anything that doesn't change. So in fixed costs, in total, that amount is going to remain the same regardless of their level of activity. I will always have to pay property taxes of $6,000 no matter how much I produce. Whereas on a per unit basis, fixed costs increase or decrease inversely with the level of activity. And what that means is as my activity level goes up, my fixed cost per unit amount would go down. For example, if I have insurance costs of $100 and I have one employee, that would mean my per unit basis would be $100. But if I have my insurance cost of $100 because it's a fixed cost is not going to change, and now all of a sudden I have 10 employees, on a per unit basis my fixed cost would only be $10 per employee. Then we have our mixed costs. Mixed costs are a portion of variable cost and a portion of fixed costs. They give us some examples here of purchasing department salaries or maintenance expenses. The example you might most relate to is your cell phone bill. If you think about that, if you don't have the unlimited plan and you have a certain amount that you get charged every month no matter what, but then let's say you go over on minutes, that would be the variable piece, and you'd have to pay more that month based on that variable piece. Let's take a closer look at what this means. So for variable cost, they vary in proportion with the changes in the activity. Therefore, if we look at it on a graph, as our units produced increased, so will the direct materials or our variable cost in total. But if we're looking at it on a per unit basis, that isn't going to change. It's going to be that $10 every unit, no matter how many units we produce on a per unit basis. Here's another example of that variable cost both on a per unit basis and in total. As you can see on that per unit basis, it doesn't change, yet in total it varies in proportion with the level of activity. As our activity goes up, our total cost will go up. Now let's take a look at how this relates to our fixed costs. Remember, in total, our fixed costs remain constant. Therefore, in that first graph, you can see how that line just stays the same. It never changes, no matter how many units we produce. Whereas on a per unit basis, you can see how our fixed costs will go down the more units we produce. Therefore, on a per unit basis, we would be paying less per unit as our production increases. Now let's take a look at these fixed costs, not in a graph form. As you can see, our salary remains constant no matter how many units we produce. Here we're talking about perfume bottles. As the number increases, our total will remain the same, but on a per bottle basis, you can see that the amount that it's going to cost per unit will go down. So as production increases, our fixed cost per unit would decrease. And finally, let's look at our mixed costs. Remember, mixed costs have both variable and fixed. Therefore, our mixed costs would start with our fixed costs because we can never pay less than what our fixed costs are. But then, with increased activity, that mixed cost total will rise. So our bottom level will be our fixed cost, and then with each additional unit, we would pay more for that variable piece. So in this graph, you can see our fixed cost would be a total of $15,000, and then we're going to be paying more for each unit we produce on top of that. Here's an example of a fixed cost. Assume that their rental charge is $15,000 per year, and then they have to pay $1 for each hour in excess of that 10,000 hour threshold. Therefore, if we used this facility for 8,000 hours, we'd have to pay that $15,000. Whereas if we used it for 12,000 hours, we'd have to pay that $15,000 fixed cost plus $1 per hour over our 10,000 hour threshold. Therefore, it's part fixed, the 15,000 piece, part variable, the $1 per hour in excess of 10,000 hours. Our job is to find out how we can pull out the components of our fixed cost and our variable cost from this mixed cost. And we can do this using the high-low method. In the high-low method, we'll get a set of data. From that data, we'll take out the highest point and the lowest point. And we'll look at the change in cost over the change in activity. This will give us our variable cost per unit. If we know our variable cost per unit, we can plug that into our total cost equation. Our total cost equation is total cost equals our variable cost per unit times our units produced plus our fixed costs. So if we know what our variable cost per unit is, we would know our total cost and our units produced from the set of data. Then we can figure out that missing piece, which would be our fixed cost. So we put in the numbers that we know, and we will solve for the unknown, which is our fixed cost. Let's take a look at an example of how to do this. They'll give us a set of data. In this case, they're showing us our units produced and our total cost. What we want to do is pull out the highest piece and the lowest piece, but you never want to separate your data. For example, our June data will always have to be together. So if we pick $45,550 as our highest cost, we'd have to take our highest activity level as 1,000 units. These are coming in one data set. Therefore, when we look at this data and we want to go find our highest level, we would go down and we find that in August, our highest cost is $61,500. Therefore, we would pick the data that goes with that, which is 2,100 units produced. And that is our highest level. Then we look to our lowest level. Our lowest total cost is $41,250. And the units that go with that are 750. Now we'll use our high-low method calculation to determine our variable cost per unit. We take our difference in our cost, which would be that $20,250, and we'll divide that by the difference in the units produced, which would be that $13.50. Now we know that we have a $15 per unit variable cost. And this will come to about the same number no matter as long as you pick the highest set and the lowest set. So what we want to do is take that variable cost per unit and we're going to plug it into our fixed cost or total cost equation. Here I just moved our equation around so that our fixed cost is what we're trying to equal, but this is the same thing. So total cost equals variable cost plus fixed cost is the same equation as fixed cost equals total cost minus variable cost. Therefore, it's just kind of taking that algebra out of the equation for you. So when we look at this, we're going to pick any point we want to. Usually you pick one that you've already used in your variable cost per unit calculation. Here we'll take our highest level. Knowing our highest costs were $61,500, and we now know our variable cost per unit is $15, with the units produced at that level of 2,100. Therefore, if we do the math, we can figure out that our total fixed cost is going to be $30,000. And our fixed cost should not change no matter which data set we pick. Therefore, if we used our lowest level, we can say our total cost minus that variable cost per unit times the units produced, put in the math, and it should still come out to that $30,000 fixed cost.